My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 424. In this lecture, I will continue my discussion on XGBoost. If you take same data and if you use sklearn implementation versus XGBoost implementation, most often I have seen XGBoost implementation gives slightly better results than sklearn implementation. I think it is mostly used because of column sampling and row sampling, and it does some code optimization much more better than scikit-learn. We can use GBDTs extensively in production environments with massive data sets. How do I install XGBoost? It's very simple. You just say pip3 install XGBoost. If you are using Python version 3, sometimes you might add sudo if you are in Linux box or if you are in Mac box. Once if you install XGBoost, let's look at this. It says you have max underscore depth. Here you have learning rate. What is this learning rate? New, which is nothing but new. Your number of estimators. What is your number of estimators? That is capital M. For a booster, just see, for a booster or for a base models, you can choose either GB tree or GB linear model. Remember, in a simple linear model like logistic regression or linear regression, this also high bias and low variance model. The most important thing is call sample underscore by trees, isn't it? Just say this, what it says, call sample underscore by trees, call sample underscore by level. What is this? Just a common thing. Is the subsample of ratio of columns. Is the subsample of, in both the cases you can see, just compare, both are related to subsample ratio of columns. This is for constructing each tree. This is related to levels. By level is related to levels. This is related to each tree, isn't it? The most important thing is call sample underscore by tree, isn't it? So when you are constructing each tree, do you want to only look at a sample of columns, which is like a column sampling, which is equivalent to column sampling, or I can say feature bagging? That's what it says. Of course, the default value, what is your default value? Default value is 1, isn't it? But you can reduce it. And at the same time, there is something called column sample by level. What it says, at any tree, when you are constructing, just you can check at the levels, isn't it? Just see, column sample by level means what? What does it mean? Just see, by level means subsample ratio of columns for each level. What does it mean? For each level means this is level, this is also level, isn't it? For each level, if you want to see how much reduction in entropy you have and how much reduction in Gini impurity you have, here what will we do? We look at all the features. And see which feature performs best. So there are two types. What are they? One is column sample by tree and another one is column sample by level. So one is to construct the whole tree. This is whole tree. Construct the whole tree. One is to construct the whole tree. Do you want to limit the number of features? Second is, at any node in the tree, do you want to limit the set of features? Isn't it? Here two ways. Those are the two ways of introducing column sampling or feature bagging into GBDT. There is something like regularization alpha and regularization lambda, reg underscore alpha, isn't it? Reg underscore alpha, and even I can say reg underscore lambda. Let's see what they are. Since we are doing gradient boosting is about solving optimization problems. When I have optimization problems, I can always do regularization. I can do regularization on gamma m's. We already discussed what is gamma m's in our previous lectures. What is my simple linear regression? W0 plus W1 xi1 plus W2 xi2 plus W3 xi3 plus so on. What is my GBDT? My GBDT is H0x plus gamma 1 into H1x plus gamma 2 into H2 of x. Here gammas are like weights. You can think of these gammas are weights and we look at them as weights. Linear regression, what is the W? Gamma 1 is just like W1, gamma 2 is like W2. In the case of linear regression is loss plus regularization, isn't it? This regularization could be L1 regularization or L2 regularization. So GBDT as implemented in XGBoost gives us the super powerful thing where it says you can have L1 regularizer alpha into L1, alpha times L1, L1 regularization plus lambda times L2 regularizer. If you want sparse GBDT, what is sparse GBDT? Here most of the useless ones here and not so useful ones becomes 0. Thus gamma 1, gamma 2, gamma 3, so on. Whichever is not useful, they will become 0. This is very powerful thing in sparse GBDT, especially if you want to limit the number of base learners because of low latency requirements or anything like that. Then you can actually try this regularization as implemented in XGBoost has interface. As implemented in XGBoost, it has interface with scikit-learn. You can still work with the scikit-learn interface. XGBoost GitHub library, I request all of you to go to GitHub libraries related to XGBoost. If you Google search for XGBoost sklearn example, just Google search these things. What you can Google search XGBoost, I can say you can Google search for XGBoost sklearn examples. Isn't it? If you look at the code there, you can see different documentation, different types of codes related to XGBoost. Just to go through all these things. If you have any if there is any difficulty, please keep a comment, but I request you to go through entire documentation related to XGBoost in GitHub also. Thank you very much.